Welcome to the Microsoft Power BI Data Analyst Associate PL300 Question Bank Series. In this video, I've got 10 exam-style practice questions lined up for you, covering the kind of Power Query data preparation, data modeling, DAX measures and time intelligence, report visualization, and analytics scenarios you'll see on the real PL300 exam. Each question comes with the correct answer and a full explanation, including why the wrong options are wrong. Here's how to get the most out of this. When a question appears, pause the video, pick your answer, then hit play to check yourself. Ready? Let's dive in. Question 11. Prepare the data. A data model for Solace Home Goods includes a sales fact table, one row per transaction line, with product ID, store ID, customer ID, date key, quantity, revenue, and separate products, stores, customers, and dates tables that each contain descriptive attributes with no numeric transaction data. In star schema terminology, what role do the products, stores, customers, and dates tables play? Option A. They are fact tables because they contain the primary keys used in relationships. Option B. They are dimension tables providing descriptive context and filtering attributes for the numeric measures in the sales fact table. Option C. They are bridge tables used only to resolve many-to-many relationships. Option D. They are staging tables that should not be loaded into the final model. Take a moment and make your choice. The correct answer is B. They are dimension tables, providing descriptive context and filtering attributes for the numeric measures in the sales fact table. Here's why. In a star schema, dimension tables hold descriptive attributes, product name, store city, customer segment, calendar date, used to slice, filter, and label the numeric facts. The sales table with its measures is the fact table, and products, stores, customers, dates are its surrounding dimensions. Now, why the others are wrong? A. Fact tables hold the measurable, quantitative transaction data, like revenue and quantity. Tables that only hold descriptive attributes and a key without numeric transaction measures are not fact tables even though they contain keys. C. Bridge tables specifically resolve many-to-many relationships between two other tables and typically contain only key columns. That is not what is described here, since these tables hold rich descriptive attributes and relate directly to sales. D. There is no indication these tables should be excluded from the model. On the contrary, dimension tables are essential for filtering and labeling fact data in reports. Question 12. Prepare the data. An analyst has a query named raw transactions that performs several cleaning steps. Two different downstream needs exist. One, a query called daily summary that further groups raw transactions by date without needing the cleaning steps to rerun independently. And two, a completely separate query called archive export that starts from the same cleaned data but will later diverge with its own unrelated transformations, while both should stay in sync if the original cleaning logic changes. The analyst wants each new query to build on raw transactions output without copying its M code. Which two Power Query actions should be used for daily summary and archive export respectively? Option A. Create both as reference queries pointing to raw transactions. Option B. Duplicate the raw transactions query for both daily summary and archive export. Option C. Use reference for daily summary and archive export interchangeably. It makes no functional difference versus duplicate. Option D. Merge raw transactions with itself twice, once for each new query. Take a moment and make your choice. The correct answer is A. Create both as reference queries pointing to raw transactions. Here's why. A reference query starts empty and simply points to the output of raw transactions as its source step. Both daily summary and archive export can be created as references so that any change to raw transactions cleaning logic automatically flows through to both, while each can still add its own additional steps afterward. Now, why the others are wrong. B. Duplicate copies all of raw transaction steps into a new independent query. Later changes to raw transactions cleaning logic would not automatically propagate to the duplicated queries, which does not meet the stay in sync requirement. C. There is a meaningful functional difference. Reference queries stay linked to the source query's logic, changes propagate, while duplicate queries are fully independent copies, changes do not propagate. So the choice does matter. D. Merge queries combines two queries by matching key columns into a single joined result. It is not a way to create an independent downstream query that inherits another query's transformation steps. Question 13. Prepare the data. An analyst is combining two Power Query tables at Faro Bytecode, orders_US and orders_EU, which have identical column structures, order ID, customer ID, amount, currency, but contain different sets of order rows from two regional systems. The goal is a single table containing all rows from both regions stacked together. Which Power Query operation should be used? Option A, merge queries, joining on order ID with a left outer join. Option B, group by on order ID across both queries. Option C, merge queries, joining on order ID with a full outer join. Option D, append queries, combining orders_US and orders_EU into one table. Take a moment and make your choice. The correct answer is D, append queries, combining orders_US and orders_EU into one table. Here's why. Append queries stacks rows from two or more queries with matching or compatible column structures into a single table, which is exactly what's needed to combine order rows from separate US and EU systems. Now, why the others are wrong. A. Merge queries joins two tables side by side by matching key values, adding columns from one table to the other. It would not simply stack the two separate row sets into one combined list of orders. B. Group by is an aggregation operation performed within a single query. It does not combine two separate queries into one table. C. A full outer join via merge still performs a column-wise join based on matching keys and could create incorrect combinations or unnecessary nulls. It is not the right tool for simply stacking independent row sets. Question 14. Prepare the data. A sales fact table imported from an external system contains a product code column formatted as SKU-00123, while the products dimension table has a numeric product ID column with values like 123. Before these tables can be related in the model, the analyst needs a matching key on both sides. Which Power Query step on the sales query would correctly derive a numeric key that matches product ID? Option A. Rename the product code column to product ID without changing its values. Option B. Use text.after_category to extract the digits after SKU-GIT. Then convert the result to whole number, removing any leading zeros as needed. Option C. Apply text.upper to standardize the casing of product code. Option D. Delete the product code column since it is not needed for relationships. Take a moment and make your choice. The correct answer is B. Use Text.AfterDelector to extract the digits after SKU. Then convert the result to whole number, removing any leading zeros as needed. Here's why. Extracting the portion of the text after the SKU delimiter with Text.AfterDelimite and then converting that substring to a whole number produces a numeric value, 123, that can align with and be related to the numeric product ID in the product's dimension table. Now, why the others are wrong? A. Simply renaming the column does not change its underlying text values, SKU-00123. It would still not match the numeric product ID values, and the relationship would fail to find matches. C. Text.upper only affects letter casing in text. It does not extract the numeric portion or convert the data type, so the values still would not match product ID. D. Deleting the column removes any possibility of deriving a matching key from it, which would make it impossible to relate sales to products altogether. Question 15. Prepare the data. In Power BI Desktop's Power Query Editor, an analyst has a query called Currency Rates Staging that is used only as an intermediate step to look up exchange rates inside other queries via merge. It should never appear as its own table in the report's data model or consume refresh time as a standalone table load. What should the analyst do? Option A. Set the query's data category to Hidden in the model view. Option B. Delete all the columns from the query except one. Option C. In the Queries pane, right-click Currency Rates Staging and clear, uncheck, Enable Load. Option D. Rename the query to start with an underscore so Power BI automatically excludes it. Take a moment and make your choice. The correct answer is C. In the Queries pane, right-click Currency Rates Staging and clear, uncheck, Enable Load. Here's why. Unchecking Enable Load, available via right-click on the query or Query Properties, prevents that query's results from being loaded as a table into the data model, while still allowing the query to be referenced merged into other queries that do load, exactly matching the staging query use case. Now, why the others are wrong? A. Data category is a modeling property, like address, city, or URL, applied to columns in the report model to enable features like mapping. It does not control whether a query loads into the model. B. Removing columns still leaves the query configured to load, even if nearly empty. It does not stop the query from being materialized as a model table, and does not prevent it from being counted in refresh operations for load. D. Power BI does not treat a leading underscore in a query name as a special instruction to skip loading. Load behavior is controlled explicitly through the Enable Load setting, not naming conventions. If you find this review helpful, please continue, and you may also want to get the complete set, all 360 exam-style questions with full explanations across every core Power BI knowledge area are available in my Udemy course, Microsoft Power BI Data Analyst Associate, PL300, Complete Exam Preparation and Practice Question Bank. The link is in the description below. Make sure you subscribe so you don't miss the next video, where I'll walk you through 10 more questions. Let's continue with the next question. Question 16. Prepare the data. An analyst building a model for Argent Beauty Supply has a large sales fact table where a notes column, free text comments entered by cashiers, is not used in any visual or measure and roughly doubles the table's storage footprint after import due to high cardinality text. What is the most appropriate action during data preparation to improve model performance? Option A. Leave the column in the model but hide it from report view using the Fields pane. Option B. Remove the notes column in Power Query before loading, since it is unused and its high cardinality text adds unnecessary size. Option C. Convert the notes column to a calculated column instead of a Power Query column. Option D. Change the notes column's summarization property to Do Not Summarize. Take a moment and make your choice. The correct answer is B. Remove the notes column in Power Query before loading, since it is unused and its high cardinality text adds unnecessary size. Here's why. Removing an unused high cardinality text column at the Power Query stage, Remove Columns, prevents it from ever being loaded into the model, directly reducing the table's memory footprint and improving compression and refresh performance, a core data preparation best practice for optimizing model size. Now, why the others are wrong? A. Hiding a field from the report view only affects its visibility in the Fields pane for report authors. The column data is still fully loaded into memory and still consumes storage and processing overhead during refresh and query time. C. Converting it to a calculated column would still load the source text into the model to compute against, and calculated columns are also stored in the model, and often compress less efficiently than Power Query loaded columns, so this would not reduce size and adds unnecessary complexity. D. The Do Not Summarize setting only affects how a numeric-like field aggregates by default in visuals. It has no effect on a text column's storage size or whether it's loaded at all. Question 17. Model the data. A model for Harlow Electronics contains a single wide table with every sales transaction, every product attribute, name, category, subcategory, brand, cost, every store attribute, city, region, manager, and every date attribute, year, quarter, month, all in one flat table, rather than separate related tables. What is the primary modeling concern with this design compared to a star schema? Option A. Flat tables are not supported by Power BI and will fail to load. Option B. Flat tables can only be used with DirectQuery, never import mode. Option C. Flat tables prevent any DAX measures from being created. Option D. It leads to repeated, denormalized attribute values across many rows, larger table size, slower performance, and harder to maintain filtering compared to a star schema of separate fact and dimension tables. Take a moment and make your choice. The correct answer is D. It leads to repeated, denormalized attribute values across many rows, larger table size, slower performance, and harder to maintain filtering compared to a star schema of separate fact and dimension tables. Here's why. A single flat table repeats dimension attributes, like product category or store city, on every transaction row, inflating table size, hurting compression, and making relationships filtering less efficient than a well-designed star schema where dimensions are normalized into separate related tables. Now, why the others are wrong. A. Power BI can load a single flat table without error. The issue is one of modeling quality and performance, not a hard technical limitation. B. Flat tables work fine with either import or DirectQuery mode. Storage mode is an independent choice unrelated to whether the schema is flattened or star-shaped. C. DAX measures can be written against a flat table just as with any table. The concern is efficiency and maintainability, not the ability to write measures at all. Question 18. Model the data. In the model view for a Vantage Furniture report, the analyst sets the Products Product Key columns sort by column property to Products Product Key itself, but once the Products Month Name column, values like January, February, to sort in calendar order rather than alphabetically in visuals. What should the analyst do to fix the month name sort order? Option A. Rename month name values to 01 January, 02 February, etc., since sort by column cannot change text sort order. Option B. Set month names sort by column property to point to a month number column that holds 1 for January, 2 for February, and so on. Option C. Mark the products table as a date table. Option D. Change month names data category to month. Take a moment and make your choice. The correct answer is B. Set month names sort by column property to point to a month number column that holds 1 for January, 2 for February, and so on. Here's why. The sort by column property lets a text column, month name, be sorted according to the values of a different numeric column, month number, in the same table. So visuals display January before February, even though alphabetically April would otherwise come first. Now, why the others are wrong? A. Renaming values to embed sort order is a workaround some use in the source data, but it is not required. Sort by column is designed specifically to solve this without altering the displayed text. C. Mark as date table is used for a genuine date table to enable time intelligence functions on a date grain column. It does not affect the sort order of a separate month name text column, and products is a product dimension, not a date table. D. Data category values like month are not a real supported data category option in Power BI. Valid categories include things like address, city, country, latitude, longitude, web URL, barcode. It would not control sort order. Question 19. Model the data. A store's dimension table in a Power BI model for Caldwell Pharmacy has a store ID column used for relationships and a separate store manager SSN column that must never be visible to report authors or exposed in the fields pane, even though it needs to remain in the table for a background lookup used by another hidden measure. What should the analyst do? Option A. Apply row-level security to the stores table. Option B. Delete the column from the model entirely. Option C. Set the Store Manager SSN column's Hide in Report View property to Yes, called simply hiding the column. Option D. Move the column into a separate calculated table. Take a moment and make your choice. The correct answer is C. Set the Store Manager SSN column's Hide in Report View property to Yes, called simply hiding the column. Here's why. Right-clicking a field or using its properties and choosing Hide in Report View hides the column from the fields pane for report authors building visuals, while it remains fully present in the model and usable in DAX expressions such as background measures. Now, why the others are wrong? A. Row-level security restricts which rows a user can see based on filter conditions. It does not hide a specific column from the fields pane. B. Deleting the column would remove it entirely, breaking the hidden measure that still depends on looking it up. D. Moving it to a separate calculated table adds unnecessary complexity and does not, by itself, hide anything. The column would still need the Hide in Report View property set regardless of which table it lives in. Question 20. Model the data. A model for Ash Grove wines contains a shipments fact table with both an order date column and a delivered date column, and a single dates dimension table related to shipments only via order date, an active relationship. The analyst needs a measure, total delivered amount, that sums shipments amount, filtered by delivered date, falling within the period selected by the dates table's slicer, without creating a second physical dates table. Which approach is correct? Option A. Write the measure using calculate with user relationship to activate the inactive shipments delivered date to dates date relationship for that calculation. Option B. Create a second active relationship directly from delivered date to dates date. Option C. Use related to pull delivered date values directly into the measure. Option D. Rename order date to delivered date in the shipments table. Take a moment and make your choice. The correct answer is A. Write the measure using calculate with user relationship to activate the inactive shipments delivered date to dates date relationship for that calculation. Here's why. When a second relationship, shipments delivered date to dates date, exists but is inactive, wrapping the measure's expression in calculate, user relationship, shipments delivered date, dates date, temporarily activates that specific relationship for the calculation, letting the measure filter by delivered date using the existing single dates table. This is the standard role-playing dimension pattern. Now, why the others are wrong. B. Power BI does not allow two simultaneously active relationships between the same pair of tables through different columns. A second relationship on delivered date would have to be created as inactive by default. C. Related retrieves a related column's value across an active many-to-one relationship for row context calculations. It does not activate an inactive relationship or filter by a different date field in a measure's calculation. D. Renaming the column would break the existing order date-based relationship and any measures depending on order date filtering, and does not solve the requirement of filtering by delivery date specifically while retaining order date functionality. And that's a wrap on this video. Nice work getting through those 10 questions. If this helped, you're going to want the complete set, all 360 exam-style questions, with full explanations across every core Power BI knowledge area are available in my Udemy course, Microsoft Power BI Data Analyst Associate, PL 300, Complete Exam Preparation and Practice Question Bank. The link is in the description below. Make sure you subscribe so you don't miss the next video, where I'll walk you through 10 more questions. See you in the next video.